Ready to go.
Part of my exercise in filling out the context of the Natural Philosophy Project is going to involve me talking a lot about my education and work experience as an engineer. I graduated from North Carolina State University with a bachelor's degree in mechanical engineering in 1983, and I passed the North Carolina Professional Engineers exam in, I want to say, about 1994. I don't keep that current anymore. And as I've said elsewhere, over time I realized that I had not been educated about how technology can be integrated into the environment, how a sustainable technological civilization can be put together from our end of things. Engineering students are not taught that. The teaching model, as far as I know, still does not exist for such a thing. And the Natural Philosopher Project here very much addresses that issue, and for the most part forms the epistemological foundation that such a sustainable engineering science, design science, as Bucky would say, could actually be constructed from. And this piece from the Natural Philosopher curriculum, by the way, all these original pieces, these are all hand-colored originals, and I draw them in AutoCAD, the engineering design software. So the title of this one is Resonance, the Physics of Music. And in my intensive ongoing study of all things musical, I ended up looking again at the physics aspect of music, and got this really wonderful book. Gosh, what's the guy's name? Okay, Music, Physics, and Engineering by Harry F. Olson. Really inspired this thing. And what I ended up doing was having the mechanical description, the physics of the mechanical system in this column here with, for your engineers out there, the position equations are here, velocity is here, acceleration is here. And then in this area here, I put it all together for the different physics equations for energy, for force, for action, etc. And as I was studying all this stuff, I realized that something very many people I'm sure have noticed, and that is that the math for these different systems, okay, we're talking about vibrations in fluid systems here and vibrations in electrical systems here, that the math in each of these different physical contexts was of the same form. In the natural philosophy verbiage, I would say that the math is isomorphic. It's the same form in each of these different contexts. And what I did was I emphasized the recursive nature of the mathematics at each level. And you may remember in the calculus and in the physics books that descriptions of position come first. Descriptions of how you take position and create velocity expressions come after that in the textbook. And then you have acceleration that takes place after that in the course of the book. Marshall McLuhan's statement about the medium is the message, that the context you're looking at is the important thing. When these concepts are portrayed in the linear form of a textbook, there is the implication that somehow position is first and nothing else is happening yet, and then velocity gets created, and then acceleration gets created. But that is not how things actually work, right? That if we're talking about the motion of a physical object, acceleration happens, quote, before velocity does, in a sense. So acceleration differs from zero before velocity does, we might say, according to the mathematics. So by describing the math vertically this way instead of linearly, it makes the intuitive understanding of the process much easier to get, because it's like, okay, we imagine, oh, there's this motion. Well, we need to think about all three levels of this ecology at the same time. And again, this logical level structure mimics natural communication and structure within the epistemography. So this piece is the template that I plan to use to rebuild the fundamentals of the engineering science curriculum. So thermodynamics, fluids, heat transfer, statics and dynamics, all of the stuff that is based on the Newtonian calculus 3-level structure where we're looking at position, velocity, and acceleration in all these different contexts. That all of that can be systematized in this way and made much more accessible for people to learn. And then this ecological structure, you know, once we start structuring the mind that way and communicating that way in a systematic way, then that's the foundation on which this next step into sustainability at the larger scale can be undertaken, or so it seems to me. Thanks a lot.